Hi, my name is Brad LaBaere.
My name is Stephen Marshall, and this is our ME416 project for FEA of heat transfer in fins.
The idea of this project was to use an FEA approach and ANSYS thermal calculations to predict the heat flux and temperature distributions in fins in order to find the optimal length. Our element constraints included a base of 1 centimeter with a temperature of 150 degrees C, an ambient temperature of 20 degrees C, a film coefficient of 50 watts per meter squared. In addition, 2 different fin geometries will be tested in both aluminum and copper.
We selected a rectangular straight fin and a rectangular pinned fin for this project. Through an iterative process, we determined the optimal length to be 12 centimeters. Using ANSYS, we generated a mesh of value 4, which is slightly more fine than the default since our solids are simple.
To properly constrain our models, we applied a temperature and convection load at the proper faces of the fins. Here they're displayed in red.
These two plots show the nodal temperatures for each setup. The aluminum ends in a slightly cooler temperature than the copper. The heat flux through the aluminum is 156,000 watts per meter squared, whereas through the copper it's 175,000 watts per meter squared. So slightly more heat flux through the copper than the aluminum.
For our pin fin, the aluminum ended in 86 degrees C and the copper in 109 degrees C. Copper is a little bit higher temperature. The heat flux in the aluminum was 219,000 watts per meter squared, whereas the copper was 258,000 watts per meter squared. This is a comparison of the thermal flux we calculated by hand and the thermal flux outputted by ANSYS. As you can see, there's a decently large difference between the two, as displayed by the percent differences. Any questions?